Hello class, this is a video tutorial on further trigonometric identities and equations. In this video, we'll be looking to graph sin x plus cos x. So let's go straight into it. Let's first recall all the critical points of sin x and cos x of all of these angles listed here. So I hope you can identify these points. But now let's find the sum of both angles. So we're looking for sin x plus cos x. You can go ahead, pause the video and try and fill out the rest of this table. So this, we should get 0 plus 1, 1. That's pi on, sorry, not pi, root 2 on 2 plus root 2 on 2. That's like saying half root 2 plus half root 2. Well, that's 1 whole of root 2. 1 plus 0 is 1. Positive root 2 on 2 plus negative root 2 on 2. Well, those two cancel. And the remainder hopefully isn't so difficult. You should have gotten negative 1, negative root 2, negative 1, 0, and 1. Now from here, let's plot these points here. So when x is 0, the sum is 1, which is what I've done there in purple. When x is pi on 4, the sum f of x plus g of x is root 2. You can check in your calculator. Square root 2 is approximately 1.4. So a little bit like that. Then pi on 2. At pi on 2, it is back to, it's back to 1. And then at 3 pi on 4, it's down to 0. Let's try and make it neat there. There we go, nice and neat. Come on, right in the middle. That's close as I can get it. And then at pi, it's at negative 1. Then at 5 pi on 4, it's at negative root 2. Remember, square root 2 is approximately 1.4. So around about there. And then from there, it's at negative 1. Try and make it a little bit more lined up. There we go. Then 7 pi on 4 is back to 0. Like so. And then at 2 pi, it's back to 1. Joining all those dots. Oops. It's not. There we go. Joining our points should look something like so. Whoops. Where's my marker? There. Something like that. As for this, that's not enough points. I'm just going to try and curve it as best I can. There we go. So that there in purple is the sum of f of x plus g of x, or sine plus cos. Now let's see if we can think of a simpler way of expressing this this equation here. Y equals sine x plus cos x. So it's rather tedious to try and graph that. You have two different graphs to worry about. So what if we could write this out using just one trig ratio? So sine, cos, or tan. So first, to start simplifying this, I want you to think about the parent function of the graph in purple. So the graph in purple, does it most closely resemble sine or cos? Well, if we were to have shifted everything that way, that would be, that looks just like cos. But if we moved it a bit more this way, we could probably have seen it go back to 0 like so. Well, that would have been sine. Well, from that, so the parent function, it actually could be sine, or it could be cos. We're unsure which one exactly. So it could be both. Okay. The amplitude, well, this one we can see definitely. Its highest point here is square root 2, and its lowest point here is negative square root 2. Well, its amplitude is just square root 2. So already our graph or the equation might be sine square root 2 sine x or square root 2 cos x. So it might be one of the two. Its period, well, if you take a look, it starts at 1 and ends in 1. Well, that's one full cycle. Well, its period's nice and easy. That's just 2 pi, which means the value of the coefficient of x is still just 1x. If the period had been something else, let's say pi, that would mean it would have been 2x. But because it's just a period of 2 pi, it's just sine x or cos x. The mean or the center, meaning where does the graph swing back and forth along? Well, right in the middle, it goes up along 0 and down along 0. So it's still at 0. So 0. As for its phase shift, what this means is if we were to compare it to, let's say, sine, okay, if we were to compare it to sine, so sine starts like this. Well, this looks to be the case that if it continued, okay, if it continued, it would have started there. Well, it has been moved a distance of pi on 4 to the right or the left. Well, if it had been cosine starts here. Well, cosine, if it starts here, for this purple graph to have started like as if it were cosine, it would have been like that. So that means it would have been shifted to the right pi on 4. So the phase shift looks to be the case. It's going to be pi on 4. All right, well, combining all of these above features, it seems to be the case that this function that we just graphed can be simplified down to this. So instead of writing it as sine x plus cos x, we could simply write it as square root 2 sine x plus pi on 4. Well, this is where we're going to introduce this idea of another identity. Well, this is an example of how the graph f of x, a sine x plus b cos x can be simplified to one of these 4 forms. So f of x of a sine x plus b cos x can become one of these 4 forms, where r must always be bigger than 0, and the angle, known as the auxiliary angle, must always be between 0 degrees and 360. The value of r is the amplitude, as we saw here, and the angle of theta, the auxiliary angle, it can be calculated by expanding the chosen form and figuring out what that angle is. I'll demonstrate you this later on in the examples. Note that depending on which form that you take, your auxiliary angle might end up being different to another person's. So for example, if let's say any student A picks this form to answer this question, and student B picks this form to answer the same question, their auxiliary angle will be different, but the end graph, the graph that they make, should be exactly the same. So, in summary, what we're looking to do is we're looking to learn an identity where we change a sum of sine x plus cos x to become some sort of identity of one of these four. So I'll hope to see you in the next video where I take you through some of these angles here. Okay, so see you then.